This is the first lecture on our first chapter, Introduction to Statistics. First, we will start the lectures talking about an overview of statistics, and then we'll move to discuss about how data are classified. And then we will conclude the sections discussing some methods that help collect data for statistical studies. So when we hear of statistics, usually we think of graphs, right? A graph, numbers or percentages, etc. So what is the formal definition of statistics? Statistics is actually a science of collecting, organizing, analyzing, and interpreting data in order to make decisions. In my mind, statistics is not only a science, but also arguably an art of learning from data. So why do we want to learn statistics? There's a quote from Benjamin Disraeli. There are three kinds of lies, damn lies, and statistics. People can use statistics to provide misleading information, and we want to know statistics to know when statistics is misused. If you want to use data to learn how the world works, you must have statistical knowledge in order to trust your data and your results. And if you want to be a statistician, the annual average annual salary for statisticians was $84,000, and this number is collected in May 2017. And I want to show you this video of some short interviews that people gather from statisticians. They would talk about how statistics.
What I like about being a statistician is that I can apply my knowledge to various fields. You know, the healthcare industry, I can help people find new profiles to save lives and make medicine personalized, or I can go into finance or go into any area, and I feel like it's very versatile.
As I sat in class and I saw the way you could use quantitative information to make decisions, immediately I fell in love, and it became a passion from that very first statistics class.
I became a statistician because in high school I was always really good at the math classes and calculus and physics, but I wanted to study a field where I could use math and statistics in an applied way to help solve applied problems.
To me, statistics is like not choosing your major, because it just gives you a set of skills that you could apply to so many areas.
I actually finished my master's degree in social work. And while I was doing it, there was a social research course which used lots of statistics. They used the chi-squares or these. And I always interested in why, not just, you know, here is the formula, you can use it, but I wanted to know why.
Well, I started out as a pre-med, when I was starting undergraduate work. Decided I wasn't sure I wanted to do that, was undecided for a long time. But then I said I wanted to be involved in doing something where math is applied.
To me, the statistics just really open so many opportunities because whatever topic or field or science you're excited about, they're probably making data and they probably need somebody to look at it, so it could be you.
So it could be you, right? So where statistics are used? You can use statistics in medical studies, in learning about genetics, learning about epidemiologies and finding disease clusters and etc. You can use statistics in actuarial science, which is a discipline that applies mathematical and statistical methods to assess risk in insurance, finance, and other industries and professions. You can use statistics in machine learning, right? It's a scientific study of algorithms and statistical models that computer systems use to perform a specific task without using explicit instructions, relying on patterns and inference instead. You can use statistics to make financial forecasts, right? You can use statistics to decide some marketing strategies. And there's a lot more areas where statistics can be used. So have you heard about data? Whenever we want to conduct a study, we want to collect data. So what is data? Data is a set of values of characteristics and informations about one or more persons or objects. And datum is a single of data. It is a single values of a single variable. Just one datum, it is a singular data. Then when you collect the data, it's good to know how to distinguish between the data that you're collecting is from a populations or is it from a sample. So a population is a collection of all outcomes, responses, measurements, counts that you are interested in to collect. And go along with populations parameters is the numerical descriptions of the population characteristic. So P and P go together. Populations and the numerical descriptions of population is parameter. And then the sample is just a subset, a part of a populations. And when you talk about numerical descriptions of a sample characteristics, that is when you talk about statistic. So S and S go together, right? Numerical descriptions of samples is statistic. Numerical descriptions of population is parameter. Let's look at an example. Example number 1, the dean office wanted to know on average how much UW Tacoma students spend on the textbooks per year. So in 2017, a staff conducted a survey of 509 students on campus soliciting their responses. Question is, what is the populations in this study? What is the samples in this study? And what are the data collected in this study? So the populations in this study should be all UWT students. And then a sample in this study is only 509 students who responded to the survey. Okay. Great. And then what are the data that are collected in this study? So the data is what? On average, right? How much students spend on the textbook. So the amount of money per year. Okay, as you can see that the variable should be the amount of money. And when you are asked this question, you say, I would spend $100 per year, or I would spend $500 per year. So those are the data that I've been collecting. All right, so statistics has two branches. The first branch is descriptive statistics. This is a branch of statistics that involved the organizations, summarizations, and the displays of the data. That means after you're collecting the data, you want to organize the data in certain patterns, certain forms, so that you can look for patterns, look for trends in your data. And you can use different graphs to display your data. And the second branch of statistics is inferential statistics. It's the branch of statistics that involved using sample to draw or to make conclusions about the populations. When the populations is too big, when collecting all the data is not practical, people use sample, right? Just a subset or a part of the populations to use the samples in order to make conclusions about the populations. Let's look at the second example. Number 2, a survey on 550 parents in the US found that 31% support their kids financially until they graduate, and 6% provide financial support until they start college. First, determine which part of the survey represents the descriptive branch of statistic. So descriptive branch of statistic involves, again, summarizations, display. There's no display here, so we look for summarizations, which is numerical reports. So the numerical reports from the surveys is 31%, right, and 6%. So the descriptive branch of statistics should be 31% US parents, right, support their kids financially until graduating. Another descriptive branch of statistics, another representations of descriptive branch is 6% of US parents provide financial support until they start college. All right, so those are the numerical reports that we can find from this survey. And the next part is what conclusions might be drawn from the survey using inferential statistics. Conclusion could be a majority of the US parents do not support their kids financially until graduating. We can make these conclusions because only 31% would support the kids. So the rest, 69%, would not support the kids financially until they graduate college. Then the last part of this section provides us some guidelines on how to conduct a statistical study. So there are 6 steps in a statistical study. The first step is you want to identify the variable of the interest and the populations of the study. Then you can develop a detailed plan for how to collect data, which is something that we're going to talk about in the next 2 sections. And then if you use a sample, then you need to make sure that the sample is a representative for the populations. Again, the second step will be discussed in the next sections of this chapter. Once you have a detailed plan, you can go ahead and execute your plan to collect your data. Once you have the data, you can use some descriptive statistics techniques to describe your data, to display your data, or to look for patterns in your data. And the next step is you're going to use some inferential statistics to interpret your data and to make the decisions about the populations. The last step of any statistical study is to identify any possible errors that could have happened during the process of conducting a statistical study.